Hello everyone, let's continue with our lesson. Now if you remember yesterday, we already finished a few reactions of alcohol, right? So let's do a revision. Alcohol. So what are the reactions we have covered? Do you remember? The first one is combustion. Combustion, right? The second one is nucleophilic substitution, right? Similar to halogenic alkene, and we can use HCl. HCl can be generated with a salt together with the sulfuric acid concentrated in situ. Do you remember? And then we can use SOCl2, PCl3 with heating, and PCl5, right? And then the third reaction is reaction with sodium, right? So normally, if you add sodium, you will get the alkoxide ion, right? Together with hydrogen gas. Okay? And the fourth one is esterification, right? Esterification. Esterification is we need an alcohol and then we need a carboxylic acid. So the catalyst, I repeat for so many times, is concentrated sulfuric acid together with heating. So what we are doing right now is we are going to eliminate this part. So basically, can you see this is the bond between O and H, which is broken. So you pull out the water, and then you will get the ester together with water, right? Now, we have already covered these four reactions, and today we will talk about another one, that is dehydration, right? Dehydration, as the name goes, it is a kind of elimination reaction. It's just the small molecules instead of HCl like last chapter, this time is H2O. And of course, in order to perform dehydration, we need some dehydrating agents. So normally the dehydrating agents we use in this chapter is concentrated sulfuric acid, right? And then we can also use aluminium oxide. I will go back to the lecture notes and then you will see all of them. Or you can use the porous pot, okay? Or the pumice, okay? So basically what's doing here is we need one H and one OH. Remember, the H and the OH have to be connected with adjacent carbons, okay? So the water will be pulled out. So in the end, you will get a double bond together with water. Now remember, if the case is like that, let me show you. For example, here is OH, but this one, for example, is like that, and this one is H, right? Something like that. Now, when you look at this, the OH is here, but the carbon nearby does not have hydrogen, and this is not the adjacent carbon, so no dehydration can be performed for this one, even you use heating and correct reagents. Are you okay with that? Okay. Now then we go back to the notes, okay? Let us fill in some blanks together, okay? So, okay. Are you ready? Yeah, I need red. Alcohols can also undergo it's black again. Anyway, elimination reaction. Let me see, this one? In which a small still black in color. Anyway, small molecule is lost, okay, and an alkene is formed. Yeah. Colored. What happened? It's still black. Okay, anyway, as the small molecule removed from the alcohol molecule is water, so it is also known as dehydration. Okay, let me see. Why I choose red? Blue. Oh. Can anyone teach me how to change the color? Anyway, we use black. And then so the general equation will be you need an alcohol, and then we need a catalyst or a dehydrating agent, and you heat it, you get an alkene together with water. Okay. The reaction takes place when alcohol vapor is passed through a hot catalyst, as I said. Al2O3 powder, is used to increase the surface area. Yeah. 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 Surface area. Okay. Let's take a look on ethanol. Have you tried the question yourself? So basically it's CH3, CH2OH, right? So you can also write it as CH3, CH2OH. Now can you see that the OH and H, they are next to each other? So with proper dehydrating agent like Al2O3, then this water can be pulled out, right? Then you will get ethene together with water. Okay, give you one more example here. For example, if you have this one, okay, then if you heat it with aluminium oxide, what will you get? Now remember, this is a skeletal formula, so the hydrogen is contracted. As I said, this one will be pulled out, then you will get a cyclohexene together with water. Okay? Now if you're asked to draw a labeled experimental setup for dehydration, you need this one. This one is same as cracking. Can you see that? Same as cracking. So if you want to know about the important points you have to bear in mind for dehydration, you can go back to cracking. Remember, the heat is here instead of here, okay? Because if you heat it here, you are going to vaporize the ethanol directly. It will not have enough time for it to undergo dehydration. So we need to heat here because we need a hot catalytic surface for dehydration. Okay, for dehydration. Now, since the dehydrating agent isn't consumed in the reaction, so you can say that it is a catalyst, and it is also a dehydrating agent. It has two roles actually. Okay. Now let us take a look on this question together. How about I give you 2 minutes to take a look on the question first, because I want to find out how I can change the color. Okay, 2 minutes passed. Concentrates of sulfuric acid and phosphoric acid can also be used to catalyze the dehydration of alcohol. Okay, so you can remember this now, right? This one is also concentrated, remember. The alcohol and concentrated acid are heated about this degree. In the exam, you just write triangle, it's okay. Does not change chemically, so that's why it's a dehydrating agent, and it's also a catalyst because it doesn't change chemically during the reaction. Write the equations showing the dehydration of ethanol. I did it for you already, so it's CH3, CH2OH, right? And then you have the concentrated H2SO4, and you heat it. It will become alkene together with water. This is ethene. ethene, and this is ethanol. Okay? 好 If propane-1 was used instead of ethanol, name the organic product. We can draw it out first. Propane-1, right? So if you pour out the water, you will get what? You will get propane, right? Oh, let us stop here, okay? And then I will go back to you for the oxidation part very soon. I need some time to work out how to change the color when I'm writing. See you guys. Work hard. Work hard. Work hard.